I have collected few important questions of differential equation. These are taken from previous year CBSE board exams and latest CBSE sample paper. You can't miss any one of them. If you are new here, please like and share the video to your friends and subscribe the channel. Friends, our first question is find the particular solution of the differential equation x minus y whole into dy dx is equal to x plus 2y. Given that when x is equal to 1, then y is equal to 0. Friends, the solution is this one. What is given? Dy dx is equal to x plus 2y upon x minus y. It's an homogeneous differential equation. Now friends, we can write this one as 1 plus 2 into y upon x divided by 1 minus y upon x. Actually, we have divided both numerator and denominator by x, so that we are getting this one. Now, let us consider that y is equal to vx. This is the substitution of homogeneous differential equation. Therefore, dy dx is equal to v plus x dv dx. So replace this dy dx by this one. V plus x dv dx is equal to 1 plus 2 y by x. Y is equal to vx, so y by x is equal to v. So twice v divided by 1 minus v, isn't it? Or we can write x dv dx is equal to 1 plus 2v upon 1 minus v minus v. So there is an LCM 1 minus v, so that we get v square plus v plus 1, or 1 minus v upon v square plus v plus 1 dv is equal to dx upon x. Friends, we can write it as minus v minus 1, just we have taken minus common, and denominator is v square plus v plus 1 dv is equal to dx upon x. So friends, here we can write, you see that, observe that the derivative of v square plus v plus 1 is twice v plus 1, but in the numerator we have only v minus 1. So first of all, we have to divide by 2 and again multiply the numerator by 2. So we get 2v minus 2 upon v square plus v plus 1 dv is equal to dx upon x. Or we can write again minus half 2v plus 1 minus 3 upon v square plus v plus 1 dv is equal to dx upon x. Now friends, introduce the integration. Okay, now we can write from this step, we have to split it in this way, 2v plus 1 divided by v square plus v plus 1, and another part is minus 3 upon v square plus v plus 1, so that we get here minus half integration 2v plus 1 upon v square plus v plus 1 dv plus 3 upon 2 integration dv upon v square plus v plus 1 is equal to integration dx upon x. The steps are very simple, but you have to observe carefully. If you commit any mistake, then you will not be given the marks. Minus half. Now friends, since the derivative of the denominator is equal to the numerator, derivative of v square plus v plus 1 is equal to twice v plus 1. So we can write log of modulus v square plus v plus 1 plus 3 upon 2 integration dv upon v square plus v plus 1. This part can be written now v plus half whole square plus 3 divided by 4, that means root 3 divided by 2 whole square is equal to integration dx upon x. Now we can write, or minus, you may introduce a constant here, say c1, minus half log of v square plus v plus 1 plus 3 upon 2. Now you know the formula, integration dx by x plus a square is equal to 1 by a into tan inverse x by a. You know this formula, so we apply it here into 1 upon root 3 by 2, that means 2 divided by root 3 tan inverse v plus half divided by root 3 divided by 2 is equal to log of mod x plus c1. Now we take another page. From this step we can write now, friends, carefully observe, this step is also another important step, or we can write minus half log of, what is v? V is equal to, y is equal to vx, we considered it here, y is equal to vx, so v is equal to y upon x, so we can now replace the v by y upon x. So this is y square upon x square plus y upon x plus 1, and this 2 is cancelled, so we can write only root 3, 3 upon root 3, that means root 3 into tan inverse of v plus half. V is equal to y upon x, so y upon x plus half divided by root 3 divided by 2 is equal to log of mod x plus c1. Okay, now the simple calculation, we can write minus half log of, the LCM is x square, so y square plus xy plus x square, isn't it, plus root 3 tan inverse 2y upon x plus 1 divided by root 3, taking the LCM here, the LCM is twice x now, so this is equal to log of mod x. This mod x can be written now mod x square, and before that there is half plus c1. Okay, so friends, the calculation now becomes minus half log of y, only y square plus xy plus x square. Why? Because this step is very simple, you can take half common, and this log of mod x square will be cancelled by this one, this x square will be cancelled. Okay, so plus root 3 tan inverse 2y plus x divided by root 3x is equal to c, the constant c. So friends, ultimately the final step is minus half log of modulus x square plus xy plus y square is equal plus root 3 into tan inverse of x plus 2y upon root 3x is equal to c. Hence the result. This is the general solution. But what is given? There is a condition introduced. You have to actually find out the particular solution. So when x is equal to 1, then y is equal to 0. This is the general solution. Now you have to use these conditions for x is equal to 1, then y is equal to 0. So we can put it here. This is minus half log of modulus x square, means 1 square, 1 plus x into y is equal to 0, so 0 plus y square, this is also 0, is equal plus root 3 tan inverse x is equal to 1, so 1 plus 2 into y is equal to 0 divided by root 3 only is equal to c. Or log of 1 is equal to 0, so this part is fully 0 plus root 3 only tan inverse 1 upon root 3 plus c is equal to c. So friends, the value of c is root 3 tan inverse 1 upon root 3. So you can now replace this c by this constant. So from here, from 1, we can now write, friends, final step is minus half log of x square plus xy plus y square is plus root 3 tan inverse x plus 2y divided by root 3x is equal to c. C is equal to root 3 tan inverse 1 upon root 3. Hence the result, final result. So friends, this question is for 6 marks. Next question is, solve the differential equation y plus x dy dx is equal to x minus y dy dx. The question is taken from CBSE 16. So friends, first of all, x plus y dy dx is equal to x minus y, isn't it? So we can write dy dx is equal to x minus y upon x plus y. Mark it 1. And this is a homogeneous differential equation. So in homogeneous differential equation, the substitution will be y is equal to vx. Therefore dy dx is equal to v plus x dv dx. So replace this. Therefore v plus x dv dx is equal to x minus y. Y is equal to vx divided by x plus vx, or x dv dx is equal to, you can take x common and cancel, so will be 1 minus v upon 1 plus v, and this v will be transferred to right side minus v. So we can take an LCM here. X dv dx is equal to 1 plus v 1 minus v minus v minus v square, or we can write x dv dx is equal to 1 minus 2v minus v square upon 1 plus v. So friends, here 1 plus v upon v square plus 2v minus 1, and a minus sign is taken common here, so it will be taken on right side minus dx upon x, and there is dv. Okay, so friends, now we can write here half twice v plus v, half twice v plus 2 whole upon v square plus twice v minus 1 dv is equal to minus dx upon x. Now the interesting step is, why do I multiply the step by 2 and divide by 2? Because the derivative of v square plus 2v plus minus 1 is twice v plus 2, and the numerator is adjusted in this way, twice v plus 2. So friends, we can take the integration sign here, or this is obviously this will be half log of modulus v square plus twice v minus 1, and on the right side also similarly, this is minus log of mod x plus say log of c, and this is the step is log of v square plus 2v minus 1 plus twice log of mod x is equal to twice log of c. Since y is equal to vx, so we can replace this v by y upon x. So friends, we write here log of y square divided by x square plus 2 into y upon x minus 1 plus 2 log of mod x, that means log of x square is equal to 2 log of c. Okay, so we have to change the page here. Friends, now you observe that we have to make an LCM here. So friends, the LCM will be only x square. So this is log of x square. So this is y square plus 2xy minus x square plus log of mod x square is equal to 2 log of c, isn't it? So friends, we can write now log of only y square plus 2xy minus x square, because you know that log u plus log v is equal to log of u into v, so that x square will be cancelled, and on the right side we have twice log c means log of c square. So from both sides we can write now y square plus 2xy minus x square is equal to c square, and you can write it again, the final step, y square plus 2xy minus x square is equal to c1, where c1 is equal to c square. Is find the particular solution of the differential equation tan inverse y minus x whole dy is equal to 1 plus y square whole dx, given that x is equal to 1 when y is equal to 0. Friends, here we can write, this step is important, the first step is important, dx dy is equal to tan inverse y minus x upon 1 plus y square, okay? Or we can write dx dy plus minus 1 upon 1 plus y square whole x is equal to tan inverse y upon 1 plus y square. This is a linear differential equation of the form dx dy plus px is equal to q. Here p is equal to minus 1 upon 1 plus y square, and q is equal to tan inverse y upon 1 plus y square, okay? So friends, you know, we have to introduce a integrating factor. The integrating factor is here e to the power minus integration 1 upon 1 plus y square dy, that is e to the power cot inverse y, isn't it? So the solution can be given now, is given by, the step is x into integrating factor is equal to integration q into integrating factor dy plus c, or x into if integrating factor is e to the power cot inverse y is equal to integration q is equal to tan inverse y upon 1 plus y square into integrating factor, that is e to the power cot inverse y dy plus c, okay? So let us consider that cot inverse y is equal to z. Here we can write 1 upon 1 plus y square dy is equal to minus dz, isn't it? So we replace this one, x into e to the power cot inverse y is equal to minus integration z into e to the power z dz, because 1 upon 1 plus y square dy is equal to minus dz minus dz. 1 upon 1 plus y square dy is only minus dz plus c. So we can use by parts here. So friends, the step is now x into e to the power cot inverse y is equal to minus e to the power, after calculation you will get e to the power z into z minus 1. This is a simple step, plus c. So friends, this is x into e to the power cot inverse y is equal to e to the power cot inverse y e to the power z is equal to cot inverse y. Here it is cot inverse y. So e to the power cot inverse y into 1 minus, there is a minus sign, so we twisted this one, 1 minus z. So 1 minus z, z is equal to cot inverse y plus c, hence the result. So many questions. Our next question is, find the particular solution of the differential equation dx dy plus x cot y is equal to 2y plus y square cot y, where y is not is equal to 0. This is taken from CBSE 2013. Friends, this also carries 6 marks, and this is also one of the most important questions. Friends, it can be written now, dx dy plus x cot y is equal to, I again write this one, 2y plus y square cot y, okay, and the condition is given, y is not is equal to 0. This is again a linear differential equation of the form dx, the form is this one, dx dy plus px is equal to q. This is a linear differential equation of the form dx dy plus px is equal to q, where p is equal to cot y and q is equal to 2y plus y square cot y. So friends, introduce the integrating factor. Integrating factor is equal to e to the power integration p dy, and p is here cot y, so integration cot y dy, that means this is e to the power log of sin y, isn't it? So e to the power log of x is equal to x, you know this one, so e to the power log of sin y is equal to only sin y. So the solution is now becomes like this, x into integrating factor is equal to integration q into integrating factor dy plus c, or we can write x into integrating factor is sin y, so sin y is equal to integration q, q is equal to 2y plus y square cot y, plus y square cot y into integrating factor, that is sin y dy plus c. So friends, we can write 2 integration y sin y dy plus integration y square cos y dy plus c. So friends, we can write it as 2 integration y sin y dy plus, we have to introduce the by parts here, so y square integration cos y dy minus integration ddy of y square, ddy of y square means 2y integration cos y dy plus c, and this is equal to 2 integration y sin y dy plus y square integration cos y is sin y, so sin y minus 2 integration y sin y dy plus c, and these two are same, so you can cancel these two, and only y square sin y plus c. So friends, here it is, x sin y is equal to y square sin y plus c, but something is given. Here it is that there is one condition, this is not written here actually in the question, this is given that x is equal to 0 when y is equal to pi by 2. Actually you have to find out a particular solution with the given condition x, when y is equal to pi by 2, then x is equal to 0. So we have to use this one to get the value of c. So friends, again I write given x is equal to 0 when y is equal to pi upon 2. So from here we are getting 0 is equal to pi upon 2 whole square sine of pi upon 2 plus c, isn't it? and here it is c is only minus pi square upon 4. So mark it 1. So from 1 we get x sin y is equal to y square sin y plus c, and c is minus pi square by 4. So friends, this is the particular solution of the given differential equation. Question is, find the particular solution of the differential equation y e to the power y dx is equal to y cube plus 2x e to the power y whole dy. When x is equal to 0, then y is equal to 1. And this is the latest question, CBSE sample paper 18. This is supplied by CBSE, and this is one of the most important question. So friends, our solution is this one. Dx dy is equal to y cube plus 2x e to the power y upon y e to the power y, isn't it? So we can write dx dy is equal to, we split it here, y square upon e to the power y plus 2 upon y into x, or we can write dx dy minus 2 upon y into x is equal to y square upon e to the power y. It is again of the form is this one. Form is very important. Dx dy plus px is equal to q, where p is equal to minus 2 upon y and q is equal to y square upon e to the power y. Okay. So friends, the integrating factor is now this one, e to the power integration p dy. What is p? P is equal to minus 2 upon y dy. That is equal to e to the power log of 1 upon y square. That is only 1 upon y square. You know this formula of logarithm, property of logarithm, e to the power log of x is equal to only x when the base is e. So here it is e to the power log of 1 by y square base e is equal to 1 upon y square. Therefore, the general solution is now x into integrating factor, that is 1 upon y square, is equal to integration q is equal to y square upon e to the power y into if is 1 by y square dy, isn't it? So you can cancel y square and we can write x upon y square is equal to integration e to the power minus y dy plus c, or x upon y square is equal to minus e to the power minus y plus c, or the step is here x is equal to minus y square into e to the power minus y plus c y square. So friends, the condition is given. When x is equal to 0, then y is equal to 1. So to get c, we have to introduce this one. When x is equal to 0, then y is equal to 1. Therefore, x is equal to 0 means this is 0. 0 is equal to minus e to the power only minus 1 plus c. So getting c is equal to 1 upon e. C is equal to 1 upon e. So friends, actually our step is this one. So in this step, we replace the c is equal to 1 by e in this condition, in this step. So from 1 we get x is equal to minus y square into e to the power minus y plus c into y square. C is equal to 1 upon e y square. Okay, so the step we can write x plus y square divided by e to the power y minus 1 upon e y square is equal to 0. This is the particular solution of the given differential equation. Y e to the power x dx is equal to y cube plus 2x e to the power y dy. Thank you. Have a nice day.